Hello there, everyone. My name is Rondon Russell, and for my capstone project for Chem 1051, I will be explaining how ACE inhibitors relax blood vessels. ACE inhibitors are a medication usually used to relieve hypertension or high blood pressure. We can start off with what the ACE in ACE inhibitor stands for, which is angiotensin converting enzyme. As the name suggests, ACE is an enzyme which converts angiotensin 1 into angiotensin 2. Angiotensin 1 is a hormone by which itself has no function, but ACE turns it into angiotensin 2, which is known as a vasoconstrictor, which means it constricts the blood vessels. Angiotensinogen and ACE function as key components in the renin-angiotensin-aldosterone system, or some other people call it the renin-angiotensin system. This is where the plasma protein angiotensinogen, produced in the liver, is catalyzed by renin, which is released from the kidney, which forms angiotensin 1. Angiotensin 1 then comes into contact with angiotensin converting enzyme, or ACE as we already know, within the blood serum and is transformed into angiotensin 2, the vasoconstrictor. And then via receptors in the adrenal glands, it stimulates the release of aldosterone, which acts on the kidneys to stimulate reabsorption of salt and water, but it also, with angiotensin 2, directly acts on blood vessels to constrict them. And this, in accordance to Boyle's law, increases the pressure as the volume of the blood vessels are decreased. ACE inhibitors do vary in form, but all of them function to block an enzyme's active site. Essentially, the enzyme's active site is an empty spot in the enzyme where these, let me draw something for representation. We'll say this is the enzyme. The active site would be this little area where a substrate like angiotensin 1 to ACE or angiotensinogen to renin attaches to the enzyme. So we'll say A1 goes to ACE right here. And then the enzyme then acts upon it to transform angiotensin 1 into angiotensin 2. But what the ACE inhibitors actually do, they actually just fill up this little gap by essentially imitating the shape of the substrate, or in this case angiotensin 1, to block up the enzyme. Since the enzyme isn't absorbing its substrate, the enzyme actually is not able to work and is blocked off from acting upon any other substrate. So here are the shapes of ACE inhibitors. So since the inhibitor fills up the active site of ACE, instead of angiotensin 1, by imitating the shape of angiotensin 1, this in turn, throughout that lengthy pathway we discussed up above, produces far less aldosterone and angiotensin 2, which in turn does not constrict the blood vessels and essentially relaxes it in contrast to their size when the body was acting upon it. Here we can see the shapes of example ACE inhibitor and angiotensin 1. I can't actually say where exactly angiotensin 1 attaches to the ACE inhibitor. I mean, ACE. But the ACE inhibitor would in turn just clog up that space on ACE and not allow A2 to form. I think that the main connection we can make to the course is the appearance of Boyle's law, which in this whole scheme of things demonstrates the inverse proportionality between volume and pressure. Because as the ACE inhibitor works upon the ACE enzyme, this reduces the production of aldosterone and angiotensin 2, which instead of constricting, this produces a dilating effect with the absence of angiotensin 2 and aldosterone. And with that increase, that dilation, that increase in volume, re- results in a decrease of pressure, which is the exact reason why people take this medication. Another kind of connection we can make is inherent within the shapes of the inhibitor and the substrate. Obviously, these aren't fully equal, but since the inhibitors imitates one specific part of the substrate, specifically the part which binds to the active site of the enzyme, it is able to render the enzyme useless, as the enzyme can't do what it needs to do to the inhibitor, as it isn't its target substrate. And of course, this is due to all the varying bonds and intermolecular forces present in both the inhibitors and the substrates to give the chemicals that shape. One last connection I had thought about, but we hadn't really learned about this in our past semester of chemistry, is how some may think that the sorry about that, this keeps moving. So how the substrate plus the enzyme can be looked as reactants, and then we could see the product as a product. But this isn't actually true. In fact, the enzyme should be present on both areas because the enzyme isn't actually used up. And this is actually because enzymes are what is known as a catalyst, which is essentially a chemical or a kind of protein that can speed up a reaction. Thank you for listening to my presentation.